So we're moving right along in chapter 5, and we're going to be dealing with solving inequalities using addition or subtraction. So we want to go back over what an inequality is. So we don't have an equal sign. We have this little fancy symbol right here, and I know you guys have seen this before. This is what we would consider an inequalities. And there's three other types that we'll go over. So this sentence, what does it mean in words? The way I would read this in math, just like we read in English, we read from left to right. So x is greater than 1. So any solution I put in for x has to be greater than 1 to make it true. So I could put 5, 20, 5 million, whatever it is, anything greater than 1. So if I put in 4, does that make it a true statement? 4 greater than 1. Yes, that's true. If I put in 0 for x, 0 greater than 1, nah, that's not true. And then what about if I put 1 in? Is 1 greater than 1? That's not a true statement. It's equal to. So that's not a correct statement. And we want to find out if it makes it a true inequality or is it a false. So some of the things for definition purposes, an inequality is a statement formed by placing an inequality symbol between two expressions. So remember, an algebraic expression is a number, a variable, and an operation. So a couple of examples would be like the one that we just saw, x greater than 1. I'm going to go ahead and make it 11, my favorite number. You could also have something like x plus 3 greater than 11. That's also an inequality. So to be a solution of an inequality, it's the number I can put in for the variable that's going to make it true. Just like we showed in the previous one. Couldn't put in 0 because that didn't work. If I put in 0 here, it wouldn't work either. So inequalities have more than one solution. It has an infinite number of choices that you can put in for that variable. So we went over this in class, and you should have this in your journals. But remember, we're translating from words to symbols and mathematical symbols that we use. So if I said is less than, this is what that symbol would be. Is less than or equal to. So notice what was added was this little line underneath, less than or equal to. Is greater than would be this inequality. Is greater than or equal to would be this one. Now notice over here, this open circle, closed, open, closed. This is when we graph it. Okay? And we'll practice that as well. So when we graph it, we need to decide if it's going to be opened or closed. So an opened or closed circle is used to show where the solutions start. And an arrow pointing either left or right, because on the number line I can only go left or right, indicates the rest of the solutions. So we have to do something with our inequalities. So the first thing we're going to do is have to solve them. So you could pretend that instead of an inequality right here, that was an equal sign, if that helps you to get started. So n minus 8 less than 15. So I need to get the variable all by itself. So it's a minus 8, so I'm going to plus 8 to both sides. So it's going to be n has to be less than 15 plus 8. That's going to be 23. This is my inequality. Now to graph it, the way I'm going to graph it is first thing I mark down is 23. I'm not going to draw a whole number line because that's just way too much time. I like to put the numbers around. So I'm going to put 22 would be to the left, 24 to the right. And I look, so I know it's going to be at 23. And remember, this is going to be opened. It cannot equal 23. So you cannot land on 23. You can land to the left or to the right, and we'll figure out which way it's going to go. So I always plug in the one to the left. And if it's a true statement, then that's the way that the graph opens up. So I'm going to plug in 22 Is 22 less than 23? Yep. So all of my solutions are going to be to the left. So this would be the way the graph would look. So I could pick anything less than 23. I could pick 22.9. That would be a solution. All right, and so let's look at this one. Again, if you need to put that equal sign there to help you to get started, you can. We really want to look for all of the solutions, and so there's going to be an infinite number. So here we go. Y minus 7, so I'm going to add 7 to both sides. Minus 7 plus 7 goes to 0. I'm left with y is less than or equal to negative 10 plus 7. So notice I wrote this horizontal, and that could help you to solve this. A lot of students said that it was negative 17. So remember, if this was our dance floor situation, I would have 10 guys lined up, 7 girls lined up. So there's going to be more guys. So my answer is going to be a negative. And then what the difference is, 10 minus 7 is 3. Okay. So this is our final solution, our inequality. What I would do too is if you're having a hard time with adding those integers, I would make sure you're using that scoreboard way. I'm finding that a lot of students are successful with that. 10 points go to the negative, 7 points for the positive. Oh, the negative team won, so they would get the negative. And then 10 minus 7 is 3. So again, I'm going to graph it. So I put the number, so negative 3. I look to the left, it's negative 4. And then to the right would be negative 2. Remember, left is less. So as it goes down, the numbers look bigger, but they actually have less value. And it's going to be close because it could be equal to negative 3. So I can land on negative 3. I look to the left. Is negative 4 less than or equal to negative 3? That's a true statement. So that means that all of my solutions are to the left on the number line. If I was to put negative 2 in, negative 2 less than negative 3, that's not a true statement. It's actually greater than. So I can't plug in any number to the left, or sorry, to the right. All the numbers I can plug in the variable are going to be to the left. All right, so just a couple of more examples. And here we go. We want to isolate that variable. So to get rid of this plus 5, I'm going to minus 5 from each side. 5 minus 5 is 0. I'm going to be left with m. So m is going to be greater than 10. I'm going to graph it. First number I'm going to put down is 10, whatever number's in my inequality. I graph to the left and graph to the right. Now, if you want to put 12, 13, 14, and so on, you can. If we're just kind of sketching this out, I think these 3 points are sufficient. Now, it has to be greater than 10. So that means I cannot land on 10, so it's going to be an open circle. I look to the left, and I substitute it in for the variable. Is 9 greater than 10? No, not true. Okay, so all of my solutions are going to be to the right. Okay? I cannot put in any number to the left of 10. So I'll just check to make sure. 11 greater than 10? Yay, that's true. All right, and here's his last example. Oops, let me get rid of that. So again, my goal is to isolate the variable to get it by itself. So it has a minus 1, so I'm going to plus 1 to both sides. So this is going to be 7 less than t. Now this is kind of a weird way to say it, 7 less than t. In standard practice, we have the variable will be on the left side. So if I want to move my variable over, I have to change this inequality sign. So let me show you what this means. 7 less than t. If I was to read it backwards, t is greater than 7. Oh, this is the same thing, t greater than 7. So I'm going to go ahead and sketch it out. I'm going to put 7, I'm going to put 6, and I'll put 8. And it's going to be open because it doesn't have the line underneath it. It can't equal 7, so I can't capture it. So it's going to be open. I look to the left. I plug in the number to the left. And I like just to always have that strategy of looking to the left, plug it in, so you always have something consistent to apply to make sure you're doing the graph correctly. So I plug in 6. Is 6 greater than 7? No. So it's not going to open up to the left. It's going to open up to the right. And again, you could still use this inequality if I put in 6, 7 less than 6. Oh, that's not true. So it wouldn't open up that way. And then tomorrow we're going to be working on multiplication and division.